In problem 17 in section 13.1, we're going to use our skills from being able to graph parabolas that looked something like this, just to write down a random parabola. And instead of going back and doing all the work, we're just going to skim the skills that were the most useful. So for instance, being able to find the vertex of a parabola is very useful. Now notice we don't have y by itself, we have x by itself. And when we were done with chapter 11, it turned out that one of the best ways to find the vertex, we used it for problems where the numbers were awful, was to know that the x value of the vertex occurred at minus b over 2a. And then we could put that value in to the function, whatever the function was, call it f. We could put that value in, and that would give us the y value of the vertex. What we're going to do is just switch it around. These kinds of parabolas are parabolas where the x and the y are interchanged. And in fact, instead of opening up, this is going to open up to the right. Opening up is where the positive y values are. Opening to the right is where the positive x values are. So instead of x equals the opposite of b over 2a being the x value of the vertex, and then f of minus b over 2a being the y value, we're going to switch it around. So the vertex is going to have a y value of minus b over 2a, and then to find the x value, we will simply put it in. So what is the y value of the vertex going to be? The y value is going to be the opposite of b, which is the opposite of negative 4, divided by 2a. So the y value is 2. And then the x value is what you get when you put in y equals 2. So let's do that. So this is the vertex. Where's the vertex going to be? It's going to be at negative 2, 2. Now I've told you that it opens this way. How do we know that? Well, we can try some other numbers. We don't have to try just y equals 2. We could put anything we want to in. So let's put in y equals 0 right here. If you put in y equals 0, you get x equals 2. And so y equals 0, x equals 2. Looks like this point right here. And so it looks like maybe it's going to come down this way if it's a parabola. We're not quite sure how. What if we put in y equals, I don't know, 4? We also get x equals 2. So when y equals 4, x equals 2. And so we're getting this kind of thing. And so there's where our parabola is. We've graphed it, we've found the vertex, and we're good to go. So let's see what Decimals has to say about this situation. Sure enough, the vertex is where we thought it was. It goes through the point 2, 0 and 2, 4. And it has kind of a normal thickness, and it's going sideways, and we're done. We've sketched the graph. Again, we're trying to use our knowledge of parabolas from chapter 11 to kind of expand just a little bit into some other kinds of equations that have x squareds and y squareds called quadratic equations. And so this is kind of the general form for a circle where the center is at hk. Notice the center is the x value that makes this first parenthesis 0, and the y value of the center is the y value that makes this 0, and the radius of the circle, when we use this kind of equation, the radius of the circle is r. It's the square root of that number. So what kind of circle does this job? Well, we just have to build the equation. So let's try it. We have x minus 7 squared plus y minus 3 squared equals 6. How do I know? Well, the center of this circle would be at 7, 3, because 7 makes this 0 and 3 makes this 0. And the square root of the number over here is the radius, and the square root of 6 is the square root of 6. So I think that this circle has a radius of the square root of 6 and has a center at 7, 3. That'd be pretty easy to check out in decimals. So I type the equation into decimals, and sure enough, I'm getting a circle, and its center is at x equals 7 and y equals 3. It's at the point 7, 3. The radius is supposed to be the square root of 6. On my calculator, the square root of 6 is about 2.44. And notice the radius looks like it goes over 1, 2, and not quite a half. So 2.44 looks good. So it's just a little bit of knowledge about how this equation should look. We can start to get control over graphing circles. That's pretty cool. We're supposed to find the center and the radius of this circle and then sketch a graph of the circle. This is a pretty pleasant problem. The center will have an x value that makes the inside of this first parenthesis 0. That's negative 1. And a y value that makes the inside of this 0. That's negative 3. So that's where our center is. The radius is not this number. It's the positive square root of that number, which is 7. Armed with that, we can sketch pretty well. Negative 1, negative 3, negative 1, negative 3 is down here somewhere. And then we have a radius of 7, so let's go up 3, up 4 more, down about the same, right about the same. This is just kind of rough work, but our circle ought to look something like that. It has a radius about 7 units long. It's the distance from the center to the edge, and it has a center at negative 1, negative 3. Let's see what decimals has to say about this. I graphed it, but I wanted to put the center on, so I put this little point, and that's the center. And now, does it have a radius of 7? 1, 2, 3, 4, 5, 6, 7. Yeah, 1, 2, 3, 4, 5, 6, 7. Yeah. The center is at negative 1, negative 3. The radius is 7. It's the distance from this center to the edge to the circle is always 7, no matter what direction you're going. Circles sometimes are pretty easy to work with. What happens when we have an equation that we're trying to graph? And this turns out eventually to be the equation of a circle. But we don't recognize its equation. We could try to put in points, but putting in points is pretty miserable. So if we guessed, since there's an x squared and a y squared, if we guessed that it might be a circle, we could try to head for this shape using the skills we've already got from chapter 11 and see if we could put it into this shape. Because once we put it into this shape, graphing is pretty simple, really. So let's try. We have an x squared and no other x's. Let's leave that alone. And then we have a plus y squared plus 10y. And that's kind of a mystery. And then let's add 75 to both sides and bring the 75 onto the other side. So this is not true. But this is kind of like this piece. And this is kind of like this piece. And this will eventually be r squared, although it's not r squared now. Now what we need are these things to look more like what they're supposed to look like. So if we wanted to, we could call x squared x minus 0 squared. We don't have to do that, but we could do that. Now we need to complete this square. We need to write it as something squared, a binomial squared. So we know how to do that. We take the 10, we cut it in half, and we multiply that by itself. That's a skill that we've now practiced quite a bit. So I am going to add 25 to the left-hand side of the equal sign. Now I either need to subtract 25 from the left-hand side to undo that, or I need to add 25 to the right-hand side to balance it. I'm going to add 25 to the right-hand side. Now we have y plus 5 squared equals 100, and boy, oh boy, oh boy, we're there. We know where the center, we know it's a circle first of all because it matches this format, and we know where the center is. The center has an x value of 0 and a y value of -5. And we know that the radius is 10 because it's the square root of 100. And so now we can sketch it pretty easily. 0, -5 is where the center is, but there's a radius of 10. So we would have to go 6, 7, 8, 9, 10 would have to come up here. I'm going to have to scroll a little bit. So we go 10 in each direction, and that's going to be our circle. That's what this circle looks like. And so let's go over to decimals and just kind of double check our thinking because it's so easy. Sure enough, there's the center at 0, -5. And you can see the radius is 10, and that is the graph of the original function. So we've figured out that this is a circle and how to graph it pretty easily using the skills that we've already developed. Pretty cool.